determine if the panel is a delta or Y system, you need to measure the voltage between the three phases. If the voltage between any two phases is close to the line voltage 480 volts, it is a delta system. If the voltage between each phase and neutral is close to 277 volts, it is a Y system. Since the panel is 480 volts three-phase, you should choose the Scientific Atlantic Zone Defender 480 volts three-phase delta model for your TVSS protection. In most cases, the TVSS should be connected to the main lugs of the panel and enclosed within the disconnect. However, refer to the manufacturer's instructions for specific installation requirements. The 10 American wire gauge leads of the existing TVSS may not require fusing. Fusing is typically only required for surge protective devices, SPDs, rated for very high surge currents. Consult the manufacturer's specifications for the specific TVSS you have to determine if fusing is necessary. Understanding electrical panel configurations is crucial for safe and effective installation of surge protection devices. There are two primary types of three-phase systems, delta and Y. Each has distinct voltage characteristics that dictate the correct type of TVSS to use. Firstly, let's delve into the delta system. In a delta system, the three phases are connected in a closed loop, forming a triangle, hence the name delta. The voltage between any two phases, known as the line-to-line voltage, is the same as the phase voltage. In your case, if measuring the voltage between any two of the three phases yields approximately 480 volts, you are dealing with a delta system. Delta systems are often used in industrial applications where a high starting torque is required for motors. They can be configured with a center tap delta, which provides a single-phase 120/240 volt service in addition to the three-phase power. Secondly, we'll discuss the Y system. In a Y system, the three phases are connected in a star configuration with a neutral point at the center. The voltage between any phase and the neutral point is called the line-to-neutral voltage, while the voltage between any two phases is called the line-to-line voltage. The line-to-line voltage is higher than the line-to-neutral voltage by a factor of the square root of 3, approximately 1.732. In your scenario, if measuring the voltage between each phase and neutral results in approximately 277 volts, you likely have a Y system. Y systems are commonly used in commercial buildings because they provide both three-phase power and single-phase 120 volts for lighting and receptacles. For your 480-volt three-phase panel, selecting the correct TVSS is paramount. Given that you have identified your system as either delta or Y based on voltage measurements, you should choose the Scientific Atlantic Zone Defender 480 volts three-phase delta model. This is assuming your measurements indicate a delta configuration. If your measurements indicate a Y configuration, you would need a TVSS specifically designed for Y systems. Using the wrong TVSS can result in inadequate surge protection or even damage to the device itself. Connecting the TVSS properly is another critical step. Generally, the TVSS should be connected to the main lugs of the panel inside the disconnect. This provides the most direct path for surge currents to be diverted away from sensitive equipment. However, always refer to the manufacturer's instructions for the specific TVSS model you are using. These instructions will provide detailed guidance on proper installation procedures, including wiring diagrams and torque specifications. Ignoring the manufacturer's instructions can void the warranty and compromise the effectiveness of the TVSS. Now, let's address the question of fusing the TVSS leads. The need for fusing depends on the surge current rating of the TVSS and the gauge of the wiring used. In your case, the existing TVSS has 10 American wire gauge leads. Fusing is typically required for surge protective devices rated for very high surge currents, as it provides an additional layer of protection against overcurrents. However, not all TVSS devices require fusing. The manufacturer's specifications will clearly state whether fusing is necessary and, if so, what size fuse to use. Consult the documentation for your specific TVSS model to determine the fusing requirements. If fusing is required, ensure that you use the correct type and size of fuse as specified by the manufacturer. Using an undersized fuse can cause nuisance tripping, while using an oversized fuse can defeat the purpose of the protection. Furthermore, the fuse should be installed in a suitable fuse holder or disconnect switch, providing a safe and convenient means of disconnecting the TVSS for maintenance or replacement. Consider the role of grounding in surge protection. A properly grounded electrical system is essential for effective surge protection. The grounding system provides a low impedance path for surge currents to flow to ground, minimizing the voltage rise on connected equipment. Ensure that your electrical panel is properly grounded in accordance with the National Electrical Code (NEC). The grounding conductor should be sized appropriately for the service and connected to a grounding electrode system such as a ground rod or water pipe. In addition to grounding, bonding is also important. Bonding involves connecting all metallic enclosures and equipment together to create an equipotential plane. This minimizes voltage differences between different parts of the system during a surge event. Ensure that all metallic conduits, enclosures, and equipment are properly bonded together using bonding jumpers or other approved methods. Regular inspection and maintenance of the TVSS are crucial for ensuring its continued effectiveness. Surge protection devices can degrade over time due to repeated exposure to surge currents. Periodically inspect the TVSS for any signs of damage or degradation, such as discoloration, swelling, or loose connections. Most TVSS devices have indicator lights or audible alarms that indicate their status. If the indicator light is off or the alarm is sounding, it may indicate that the TVSS has reached the end of its service life and needs to be replaced. It's also important to keep the TVSS clean and free from dust and debris. Dust accumulation can reduce the device's ability to dissipate heat, potentially leading to premature failure. Use a soft brush or vacuum cleaner to remove any dust or debris from the TVSS enclosure. Furthermore, it's a good practice to keep a record of all surge protection devices installed in your facility, including their location, model number, and installation date. This will make it easier to track their performance and schedule replacements when necessary. When selecting a TVSS, consider the surge current rating. The surge current rating indicates the maximum surge current that the device can withstand without failing. A higher surge current rating provides better protection against larger surge events. Choose a TVSS with a surge current rating that is appropriate for the level of risk in your area. Areas that are prone to lightning strikes or have a high incidence of power surges may require TVSS devices with higher surge current ratings. Also consider the voltage protection level (VPR) of the TVSS. The voltage protection level indicates the maximum voltage that the TVSS will allow to pass through to connected equipment during a surge event. A lower voltage protection level provides better protection against voltage spikes. Choose a TVSS with a voltage protection level that is suitable for the sensitivity of the equipment you are protecting. Sensitive electronic equipment, such as computers and medical devices, may require TVSS devices with lower voltage protection levels. In addition to selecting the right TVSS, it's also important to implement other surge protection measures throughout your facility. This may include installing surge protective receptacles at the point of use and using surge protective power strips for sensitive electronic equipment. A layered approach to surge protection provides the best overall protection against surge events. Keep in mind the National Electrical Code (NEC) requirements for surge protection. The NEC contains specific requirements for the installation of surge protection devices. These requirements are designed to ensure that surge protection devices are installed safely and effectively. Consult the NEC for the latest requirements for surge protection in your area. It's also important to be aware of any local codes or regulations that may apply to surge protection installations. Some jurisdictions may have additional requirements beyond those specified in the NEC. Understanding the different types of surges is also helpful. Surges can be caused by a variety of factors, including lightning strikes, utility switching, and internal equipment malfunctions. Lightning strikes are the most common cause of large surge events. Utility switching can also generate surges, especially during peak demand periods. Internal equipment malfunctions, such as motor starting and stopping, can also create surges within a facility. Knowing the potential sources of surges can help you to select the appropriate surge protection measures for your specific application. Finally, remember to document everything. Keep a detailed record of all surge protection devices installed in your facility, including their location, model number, installation date, and any maintenance performed. This documentation will be invaluable for troubleshooting and for planning future surge protection upgrades. By following these guidelines, you can ensure that your electrical system is adequately protected against surge events. Remember to always consult with a qualified electrician for any electrical work, including the installation of surge protection devices. Electrical work can be dangerous, and it's important to take all necessary safety precautions. Working with electricity requires careful attention to detail and adherence to safety regulations. Always disconnect power before working on any electrical equipment and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it's best to leave the work to a qualified electrician. A professional electrician has the knowledge and experience to safely and effectively install surge protection devices and ensure that your electrical system is properly protected. Do not take shortcuts or compromise on safety when working with electricity. Your safety and the safety of others depend on it.